Hello, thank you for watching. Today's video is going to explore the origins of the double angle formula for sine. Before we get there, we're going to reveal a trick for finding areas of any triangle. Typically, to find the area of a triangle, all we have to do is take half base times height. So here's the base, we take half of that, multiply it by the height, and that will give us the area of that triangle. So it should be no surprise then that area equals half base times height. No big deal. Now, there is something else, a way to involve trigonometry. If we take theta as the angle on the left-hand corner here, notice that the three pieces of information we have is the length of B, and if we know the length of A, and we know the value of theta, that would actually be enough information to find the area of this triangle. That way we wouldn't have to find the height. In other words, if I'm given any triangle, whether it's a right triangle or not, if I know the side, angle, side of that triangle, then I should be able to find the area just by tweaking my half base times height formula. So the sine of theta equals height over A, which is the hypotenuse of the little right triangle that I cut out. And then I can solve for h. It means h is a sine of theta. And so then when I see the area formula, half base times height, I replace height with a sine of theta, and that creates a new formula. The area of any triangle can be calculated as 1/2 times the two sides in the right triangle times the sine of the angle between those two sides. So here's an example. First of all, I make sure that I have enough information in this triangle. I know the angle, I put that in radians this time, and I know the two sides that straddle that angle. So that is to say side, angle, side. This is a perfect candidate for using our shortcut for finding area. Now instead of finding the height of the triangle and using half base times height, I simply write half AB sine of C. And since I know the sine of pi over 3 is square root of 3 over 2, I have the area. So it's that simple, a neat little formula. But today's lesson is not about that, but rather about a way to find an equivalent value of the sine of 2x. And I'll talk about why that's important a little bit more later, but now let's just accept that I want to know, is there another way to express the sine of 2x? At first it seems kind of confusing because the triangle I'm given is an isosceles triangle, but not necessarily a right triangle. So how am I going to even involve the sine of 2x? Well, if you take note of the previous formula we just learned, that if you have two sides and the angle included between those two sides, side, angle, side, that you can calculate the area as 1/2 the two sides multiplied together, p times p is p squared, times the sine of 2x. But I would like to explore the area of this triangle in another way. I'm going to take the isosceles triangle and cut it in half. That way the length of the base of half the triangle is q over 2, and the height is still the height, but then the angle is now x instead of 2x. So what I can do now is involve sines and cosines of x instead of 2x and see where it takes me. First of all, let's accept the fact that the area of the larger triangle is in fact half base times height. The base is q, so half of q times the height equals the area of this triangle. We already know this. But now I can observe from this picture that the cosine of x is actually h over p. So here's h, here's p, and here's x. The cosine of x is h over p because it's a right triangle. Therefore, p times the cosine of x is h. Similarly, I can find the sine of x being q over 2 over p. Multiply both sides by p, and I get half of q is equal to p sine of x. Well, if I have half of q being p sine of x, then I replace half of q right here with p sine of x. And since h is equal to p cosine of x, I'm going to replace h with what I see now, p cosine of x. Clean it all up, we got p times p, we got lots of p, so we're going to square it. P squared sine x cosine of x. At this point, you should recognize that the area should be the same. Whether I use half base times height or I use half AB sine of C, I should end up with the exact same area. So in other words, this expression should be the same as this expression. Now if I simply divide both sides by p squared, which is a constant, so I don't have to worry about eliminating solutions, and then I double both sides, I end up with this formula. Boosh. And this is a really important formula. IB seems to love this one. It's one of the easiest identities to remember. So one of the things you want to do is memorize it, but the other thing you can do is appreciate how this formula emerges by combining two unique facts together. The challenge I'm going to leave you in class the next time we meet, or I might have already done this already, but what about the double angle formula for the cosine? Cosine of 2x is equal to what? Now, I'll tell you right now that the clue or the hint is you would have to use the cosine rule, also known as the law of cosines, which is prior knowledge base. So we need to know the law of cosines, and using the law of cosines in this picture, one of these pictures, we should be able to develop a cosine formula in much the same way that we developed our sine formula for double angle identities. So there it is. There's your challenge. We'll talk about that more later, hopefully, and thanks for watching. Have a good day.